Hello everyone, how are you all? I hope you keep a fine, okay? And I had said to you, okay, we will meet to you with a new topic. So today I will start new topic. Your your new topic is nitric acid. A nitric acid chapter number 10. Okay. So today I will discuss about nitric acid. And in detail, nitric acid, what is the formula of nitric acid and its molecular mass, method of preparation, laboratory preparation, and physical property of nitric acid, and then I will discuss chemical properties of nitric acid, then test of nitric acid and industrial uses. Okay, and it is a very important exam point, this chapter. Okay, and 10 marks questions come from this section of the section A of second question. It is a figure based questions come from this chapter. So get on the topic, nitric acid, chapter number 10. Nitric acid is made up of the hydrogen, nitrogen, and oxygen. So its molecular formula of nitric acid is HNO3. The formula of acid is nitric acid is HNO3. And the molecular mass of the nitric acid, atomic mass of hydrogen 1 and nitrogen 14 and single oxygen atomic mass 16 into 3 48 and total 63U. 63U. The molecular mass of nitric acid is 63U. And the structure of the nitric acid, HO single bond N double bond O and coordinate bond with a oxygen. So it is a structure of nitric acid. Okay, and in this structure nitrogen shows the valency 5. How many shows the valency? 5 valency. And the nitric acid is a oxy acid of nitrogen, and there are the two oxy acid of nitrogen found in the nature. One is the nitrous acid and the second is a nitric acid, and the formula of the nitrous acid HNO2, nitrous acid, and the nitric acid HNO3. What is the oxy acid? When any non-metal, when OH group is attached from the any non-metal, then is said to be the oxy acid. In this structure, you are looking the OH is attached from the nitrogen, means a hydroxy group attached from the non-metal, means that's why HNO3 is a oxy acid of nitrogen. Got it everyone? Yes. Get on the next point. Next point is your discovery of nitric acid. In the 1658, Glauber prepared the nitric acid with the concentrated sulfuric acid and the potassium nitrate, and the name it the nitric acid. Who prepared the nitric acid? Firstly, Glauber. Glauber prepared the nitric acid with the sulfuric acid and the potassium nitrate. In which year? 1658. And the 1776 Lavoisier proved that nitrogen acid contains the oxygen. Or you know very well the nitric acid contains the 3 oxygen. one oxygen is attached by the double bond and one oxygen is attached by the coordinate bond, and the one oxygen is attached from the nitrogen, and with the and oxygen from the oxygen attach a hydrogen. Clear? This double bond one oxygen, it is coordinate bond and it is single bond. Clear? Next is your, after that the Lavoisier later in the 1784, in the 1784 Cavendish determined its the composition. Who tells about who determined the composition of this nitric acid? Cavendish. In which year? 1784. Okay. Next topic is your the occurrence of nitric acid. Next topic is your occurrence of nitric acid. Occurrence of nitric acid. And the nitric acid are found in free state first as well as combined states. And in the form of the free state, nitric acid are found in the rainwater when it occurs in the trace after the lightning. Okay, in the free state, nitric acid found in the rainwater where it occurs in the traces after the lighting process. Clear? And in combined state, the nitric acid found in the form of metallic nitrate. Which nitrate? Metallic nitrate. For example, chili saltpeter. NaNO3 is called a common name chili saltpeter, and its chemical name is a sodium nitrate, NaNO3. It is a very important name, common name. And Indian saltpeter, it's a formula KNO3 potassium nitrate. So in the free form, the nitric acid are found in the rainwater when it's occur in the traces after the lightning. But in the combined state found in the form of the metallic nitrate, for example, chili saltpeter NaNO3 and the potassium nitrate Indian saltpeter KNO3. Got it? About the, it is all about the occurrence of the nitric acid. Next topic is your formation of nitric acid in the atmosphere. How nitric acid form in the atmosphere? During the lightning discharge, the nitrogen present in the atmosphere, you know very well, nitrogen present in the atmosphere, how much? 70, near about the 78%. Okay. Sorry, by the mistakes I have said to you 70, yes, near about 78%. And the atmosphere react with the oxygen and to form the, first it form the nitric oxide. When atmospheric nitrogen react with the oxygen at a 3000 degrees Celsius, means during the lightning discharge, then it will form the nitric oxide. Clear? Next, after this reaction, nitric oxide further oxidized to the, nitric oxide is further oxidized to the nitrogen dioxide. Nitrogen dioxide. And further, this nitrogen dioxide dissolve in the atmospheric moisture or rainwater in the presence of oxygen of the air, form nitric acid in the free state, which is washed down by the rain. Clear? Means the nitric oxide, nitrogen dioxide react with the water and oxygen means rainwater, then it will form which acid? Nitric acid. Clear? means the formation of nitric acid in the 3 steps. First step, atmospheric nitrogen react with the oxygen, then it will form the nitric oxide, and further nitric oxide oxidize into the nitrogen dioxide, and the last, when the nitrogen dioxide react with the rainwater and oxygen, then it will form the final product nitric acid. So you can obtain the nitric acid by this process. The conversion of the free atmospheric nitrogen into useful nitrogenous compounds in the soil is known as the fixation of the atmospheric nitrogen. Means the conversion of free atmospheric nitrogen into useful nitrogenous compound in the soil is known as the nitrogen fixation. Okay, and this process occurs mainly by the plants, in the plants. Okay, nitrogen and fixation, nitrogen fixation occurs in the plants nodules, in the especially nodules present in the roots. Okay, the acid was formerly known as aqua fortis. What it means? Aqua fortis, and the aqua fortis meaning is strong water. Aqua fortis means strong water, and it is so called because it react with the nearly all metals and convert them into the soluble nitrate. So why it is so called? Because of the strong water, because of it react with the nearly all metal and convert them to soluble nitrate. Clear? And it conversion, it can even dissolve silver, which does not dissolve in the other acid. In the other acid. Clear? Next topic is your laboratory preparation of nitric acid. Okay? Everything is okay? Yes?
Yes, sir.
Laboratory preparation of nitric acid. Reactant, when the concentrated H2SO4 is react with the potassium nitrate or the sodium nitrate at a 180 to the 200 degrees Celsius, then it will form first potassium hydrogen sulfate and the nitric acid. It is a what? Potassium hydrogen sulfate, and it is a what? It is a nitric acid. When concentrated H2SO4 react with the sodium metallic nitrate at 180 to 200 degrees Celsius, then it will form sodium or potassium hydrogen sulfate and the nitric acid, and the mixture equal parts by weight. Okay, means the H2SO4 and the potassium nitrate mixtures equal parts by the weight, means the taken the ratio 1:1. It is a reactant, and the product potassium hydrogen sulfate and the nitric acid, and it is a arrangement of the apparatus. Okay, equipment for the laboratory preparation of nitric acid, and it is a glass retort. Clear? And the glass retort contains the concentrated H2SO4, and concentrated H2SO4 is a non-volatile, and potassium nitrate. On heating, it will form the brown rings, brown fume, and then the pass into the okay, this into the another contain, okay, and form the nitric acid. Clear? Here on heating, it is taken in the glass retort, potassium nitrate and the concentrated sulfuric acid, glass retort, then it will form here brown fume, okay, then the washed away the nitric acid. Collection. The vapors of the nitric acid are condensed to light yellow liquid by the chilling the receiver with the running cold water. The vapor of the nitric acid are condensed to a light yellow liquid by chilling the receiver with a running cold water. Note, pure acid is a colorless, means the nitric acid, pure acid, then it is a colorless, but the acid obtained in the laboratory is slightly yellowish color, the yellow color is due to the dissolution of the reddish brown color NTO in the dinitrogen oxygen in the acid. Means the color yellowish color of the acid, nitric acid, is due to the presence of the N2O. Okay, always keep in mind this point. And this gas is the produced due to the thermal decomposition. This gas is produced due to the thermal decomposition of portion of the nitric acid. Means the on decomposition of nitric acid, then it will form the H2O, nitrogen dioxide and oxygen. Got it, everyone? Point. The yellow color of the acid remove means the process which by which you can remove the yellow color of the acid is remove. You know very well, the yellowish color of the concentrated nitric acid is presence due to the N2O. If dry air or CO2 is bubbled through the yellow acid, the later turns colorless because it derives out the NO2 from warm acid, which is the further oxidized to the nitric acid. Clear? If dry air CO2 is bubbled through the yellowish acid, the later turns it into the colorless because it drives out the NO2 from warm acid, which is the further oxidized into the nitric acid. Clear? Second point, by the addition of the excess water, nitrogen dioxide gas dissolve in water, thus the yellow color of the acid is removed and the reaction is the reverse of the decomposition of the nitric acid. Means you can remove the yellowish color of the nitric acid by the dissolving of the N2O in a water. Got it, everyone? Yes. Get on the next point. Precaution of this reaction. Precaution. All the glass apparatus is used because nitric acid vapors attacks and rubbers and cork. Clear? So all glass apparatus is used in this process because nitric vapors attacks rubbers and cork. And concentrated HCl, for the method of preparation of the nitric acid, never use the concentrated HCl is not used in the place of the concentrated H2SO4 because of the HCl is a volatile. HCl is a volatile, hence nitric acid vapors will carry HCl vapors. Okay, and whereas the concentrated H2SO4 is a non-volatile in nature. Clear? Means for the formation of nitric acid, never use the concentrated HCl. Next point, the temperature of the reaction should not exceed 200 degrees Celsius, because of when the sodium nitrate and the sodium hydrogen sulfate react at greater than the 200 degrees Celsius, then it will form the what? Sodium sulfate. What? Sodium sulfate. It is a sodium sulfate and it is a what? Nitric acid. Nitric acid means the sodium sulfate formed at the higher temperature from the hard crust which is stick to the wall of the retort and it difficult to remove. That's why always for the formation of the nitric acid, the minimum temperature means the below the 200 degree Celsius. Otherwise, the formation of the at a higher temperature, sodium sulfate will form in this reaction, and this sodium sulfate which is stick to the wall of the retort and it is difficult to remove. Okay, so this reaction always occurs at the lower temperature, means the less than 200 degrees Celsius. The higher temperature, if this reaction occurs at the higher temperature, means more than the 200 degrees Celsius, then may damage the glass apparatus. Decomposition of nitric acid can also occurs, and the wastage of the fuel. So there are the three causes. Okay, means the if we reaction occurs at a higher temperature, then it is a disadvantage of the higher temperature. May damage the what? Glass apparatus, and the damage of the nitric acid, decomposition of nitric acid can also occurs, and the wastage of the fuel. Got it, everyone? Next is your manufacture of the nitric acid. Manufacture of the nitric acid by the Oswald process. In the Oswald in the 1914, and Oswald was a German chemist. Oswald in the 1914 developed the Oswald process, and the Oswald process by which you can obtain or manufacture of the nitric acid. In this process, the process is explained in the 3 steps. Okay, first, catalytic oxidation of ammonia. Second, oxidation of the nitric oxide in oxidation chamber. And the third, absorption of the N2O dinitrogen oxygen in water. Mean the Oswald process, there are the 3 steps. First step is your catalytic oxidation of the ammonia. Second, oxidation of the NO in oxidation chamber. And the third, absorption of the N2O in water. Okay. First step is your catalytic oxidation of ammonia. Okay, and the mixture of the dry air free from the carbon dioxide and the dust particle and the dry ammonia in the 10 ratio by 1 by volume. Okay, the mixture of air and the dry ammonia NH3, and taken in the which ratio? 10 ratio 1. Compressed, and the mixture of dry air and the ammonia compressed, then pass into the catalytic chamber and the 800 degrees Celsius, and the chamber containing platinum gauge, and platinum gauge as a what? As a catalyst. as a catalyst. When ammonia is oxidized, okay, in the presence of the catalyst PT at 800 degrees Celsius, then it will form the NO, nitrogen oxygen, of and also form the water, and the lots of the heat is produced. And this reaction is a highly exothermic, and the heat evolves and maintains the temperature of the catalytic chamber. Okay, this reaction is a highly exothermic. The hot gases are then passed through a heat exchanger, cooling chamber, and then they are mixed with air and passed into another chamber called the oxidizing chamber. Okay, so it is a process. First process, catalytic oxidation of ammonia, and the which catalyst is used for this reaction? Platinum gauge as a catalyst. Next step is your oxidation of nitric oxide. Oxidation of oxide in oxidation chamber. In oxidation chamber, nitrogen oxide further oxidize at a 50 degrees Celsius, then it will form the nitrogen dioxygen. Nitrogen dioxygen. Okay, and third step, absorption of the nitrogen dioxygen in a water. The nitrogen dioxygen together with the remaining air is passed through the absorption tower. Absorption tower, a steel tower filled with the quartz stone and packed in a layer. Okay, in third step, nitrogen dioxide together with the remaining air is passed through the absorption tower, and from the top of which warm water trickles. Warm water trickles. Clear? Nitrogen dioxide and the oxygen air react with the water. Nitrogen dioxide and the oxygen present in the air react with the water and to form a what? Last is a nitric acid. Means the nitrogen dioxide further react with the water and oxygen and finally gives the what? Nitric acid. Clear? So it is a whole process of the manufacturing of the nitric acid by the Oswald process, and in this process I have discussed, okay, 3 steps. First, catalytic oxidation of ammonia, and the second is the oxidation of the nitric oxide into oxidation chamber, and third, the absorption of the nitrogen dioxide in a water. Clear everyone? Oswald process. The nitric acid obtained at the bottom of the tower is concentrated above 50%, and the above acid on the further distillation gives the 68 per nitric acid, and this acid is a concentrated nitric acid which is used in the laboratory. Okay, means the concentrated the nitric acid is a percentage of the nitric acid 68%. Okay, yes, and it is the whole process, means the Oswald process. Here the taken the 1 volume of the ammonia and pass the air 10 volume, means the mixture of the air and the ammonia 10:1, and pass in the catalytic chamber at 800 degree Celsius, and it is about platinum wire gauge. Platinum wire gauge, and it act as a catalyst. It act as a catalyst. Okay, then it is from the this In this chamber, on the oxidation of the ammonia and the air, then it will form water, nitric oxide, and this nitric oxide further send into the oxidizing chamber and form the nitrogen dioxide, and finally nitrogen dioxide transfer into the absorption tower, and finally nitrogen dioxide oxygen react with the water and oxygen, then it will form the nitric acid HNO3, and the the percentage of the concentrated nitric acid is near about the 68%. Okay, yes, and finally on the, if you want the more concentrated H2SO4 nitric acid, so by you can the dehydration you can obtain the 98% concentrated nitric acid. Clear? Ammonia and the air convert into the pass from the wire gauge, platinum wire gauge, okay, and then it will form the nitric oxide, and further nitric oxide oxidize into the nitrogen dioxide in oxidation chamber, and then nitrogen dioxide is transferred into the absorption tower and finally form the 68 or the 60% of the nitric acid. Okay, it is a whole process, Oswald process. Then the concentration of the nitric acid up to 98%, fuming the nitric acid, means the fuming nitric acid is called 98%, is obtained by the distilling 68% nitric acid over the concentrated sulfuric acid, means by the this process you can obtain the 98% concentrated nitric acid by the distilling of the 68% nitric acid over the concentrated sulfuric acid. Okay, pure 100% nitric acid is obtained by the strongly cooling the 98% acid when colorless crystal of pure nitric acid get separated at a minus 42 degree Celsius. In the manufacture of the nitric acid, note, in the manufacture of the nitric acid, higher ratio, if you will take the higher ratio of air is used in this process, because oxygen is only 1/5 in air, it is required in the 3 chamber. Okay, next, quartz is acid resistant, and when packed in a layer it help in the dissolving nitrogen dioxide uniformly in a air. So it is what the manufacturing of the nitric acid. So always take the higher ratio of the air. And next, quartz is used acid resistant, and when packed in the layer it helps in the dissolving nitrogen dioxide uniformly in air. So it is all about the Oswald process, and by this process you can manufacture or the production of the nitric acid. Next topic is your properties of nitric acid. Yes, next topic is your the properties of the nitric acid, and first of all we will discuss about the physical property of nitric acid. Nitric acid is a colorless liquid, means the colorless liquid. Which type of the acid? 98% concentrated nitric acid is a colorless liquid. And the commercial acid, nitric acid, 68% is yellowish due to the presence of the N2O, means the yellowish brown in color, and it's a suffocating smell, and acidic in nature, means the sour taste, and hygroscopic, and fumes in air. Okay, and the density of the nitric acid 1.5 gram per centimeter cube. It is a density of the 98% concentrated nitric acid, and the commercial density 1.42 gram per centimeter cube, 68% nitric acid, and it's a BP of nitric acid boiling point 86 degrees Celsius, and the MP minus 42 degree Celsius. An aqueous solution of the nitric acid 68% concentrated from the azeotrophs at 121 degree Celsius. Mean the aqueous solution of nitric is 68% of nitric acid from the azeotrophs at 121 degree Celsius, means it's boil the constant boiling point, and the nitric acid soluble in water in all proportion, and the nitric acid non-poisonous, corrosive action on the skin, painful, and the painful blisters. Nitric acid react with the protein of the skin and form the xanthoprotic acid. It is a phenol. On oxidation of the nitric acid, it will give the orthonitrophenol, and xanthoprotic acid is used as the detection of the aromatic amino acid. Clear? Xanthoprotic acid will what? Use the detection of the aromatic amino acid. Next, chemical properties of the nitric acid. Chemical properties of nitric acid. Stability of the nitric acid. Pure nitric acid unstable to heat or sunlight. It decomposes on the heating in the presence in the sunlight. Okay, then it will give the nitrogen dioxide, water, and oxygen, and this solution is yellowish color. That's why HNO3 is stored in the bottles turns into yellow, and the avoid of the decomposition, nitric acid is stored in the colored bottle. Why they kept the nitric acid colored in bottle? To avoid of the decomposition of nitric acid, and the 100% nitric acid is not used. Clear everyone? Yes, so it is about the stability of the nitric acid. Next, acidic property. Nitric acid is a very strong monobasic acid. Monobasic means when on dissociation, on the dissolving, then it will give the H plus and the NO3 minus, and in the aqueous solution, it will convert the blue litmus paper into the red litmus, means the acidic in nature, and the methyl orange convert pink. Okay, and phenolphthalein remains the colorless because of the concentrated nitric acid is a what? Acidic in nature. So means the nitric acid HNO3 is a what? Acidic nature, acidic property of nitric acid. Next point, next reaction with the alkalis. Means base. Base K2O, copper oxide, zinc oxide, sodium hydroxide, when react with the dilute acid, means the dilute nitric acid, then it will form the salt and water. You know very well, this reaction is called what? Neutralization reaction. Which reaction? Neutralization reaction. Neutralization reaction means when acid react with the base, then it will form the salt and the water, and this reaction is called neutralization reaction, because of the base neutralizes the effect of acid. Okay, then it will form the salt and water. For example, iron, it is ferric hydroxide, nitric oxide, then it will form what? Then it will form what? The nitrate, okay, ferric nitrate, FeNO3 and the plus ferric nitrate and the water, and the magnesium, then it will form the magnesium hydroxide react with the dilute nitric acid, then it will form the magnesium nitrate plus water. Clear? Means acid react with the base, then it will form salt and water. It is a salt and it is a water. Reaction number third, reaction with carbonates and the bicarbonate, means the acid react with the carbonate and the bicarbonate, then it will give the form salt, water, and but release the carbon dioxide in case of carbonate and bicarbonate. Carbonate means CaCO3, bicarbonate means NaSCO3. Okay, it is the sodium carbonate, it is a copper carbonate. So nitric acid react with the calcium carbonate, then it will form the calcium nitrate, water, and the carbon dioxide. Similarly, nitric acid react with the sodium bicarbonate, then it will form the calcium nitrate, sodium nitrate, water and carbon dioxide, and also react with the HNO3, then it will form sodium nitrate, Na sodium nitrate, H2 and carbon dioxide, and this also it will form the what? Sodium nitrate plus water and carbon dioxide, and the copper nitrate plus water and the carbon dioxide. Got it, everyone? Means that when acid react with the carbonate and bicarbonate, then it will form the salt, water, and the carbon dioxide. Next, action with the metallic sulfide. Action with the metallic sulfide and the bisulfide, then it will form the what? Metallic nitrate, water, and gives the sulfur dioxide gas. Which gas? Sulfur dioxide gas. So K2SO4 react with the dilute nitric acid, then it will form the potassium nitrate, water, and sulfur dioxide. Similarly, copper sulfate, okay, react with the copper bisulfide, react with the dilute acid, then it will form the copper nitrate plus water and the sulfur dioxide. And it is a what? Calcium hydrogen sulfide, react with the dilute nitric acid, then it will form the copper nitrate plus water plus sulfur dioxide. Clear? Oxidizing properties of the nitric acid. Nitric acid vigorously oxidize non-metal and is inorganic compounds and the organic compound. Mean nitric acid vigorously oxidize non-metals and the inorganic compounds and organic compound. Means the nitric acid is a highly oxidizing agent. Okay. Nitric acid itself undergoes a reduction to form the different reduction for product like NO, NO2, N2O, etc. Okay. So nitric acid itself undergoes reduction to form the different reduction product like NO, nitrogen dioxide, dinitrogen oxygen and the etc. Oxidizing property are due to the nascent oxygen which is get given on the decomposition. Okay, so nitric acid is a what? Highly oxidizing agent, and the oxidizing property of the nitric acid is due to the nascent oxygen. Due to the nascent oxygen, this oxygen is called nascent oxygen. Nascent oxygen. Concentrated nitric acid on decomposition, it will give the nitrogen dioxide plus water and the nascent oxygen, and the dilute nitric acid gives the nitric oxide plus water and the nascent oxygen. HNO3 is a powerful oxidizing agent. The nascent oxygen form on the decomposition oxidize the hydrogen to form the water. So nitric acid is a what? Nitric acid is a powerful oxidizing agent due to the presence of the nascent oxygen, and nascent oxygen form on the decomposition oxidize the hydrogen into water. Okay, so got it everyone? Yes. Next is your action on the non-metal. Action on non-metal. When non-metal react with the concentrated acid, then it will form the oxidized product water and the nitrogen dioxygen. Carbon, for example, carbon react with the concentrated nitric acid, then it will form the carbon dioxide, water and the nitrogen dioxide. Similarly, sulfur react with the concentrated nitric acid, then it will form the what? Sulfur dioxide plus water and plus the nitrogen dioxide. So it is a reaction action on the non-metal. Next is your action on the metal. When nitric acid is react with the all metal except gold and the platinum, means nitric acid react with the all metal but except gold and platinum, and it depends on the temperature and the concentrated nitric acid. Okay, reaction with cold. First, cold and the dilute nitric acid. Cold and dilute nitric acid. When the copper, zinc and iron react with the dilute nitric acid, then it will form the copper nitrate, water and the nitric oxide. It is what? Nitric oxide. Okay, at cold and the dilute nitric acid. But in case of similarly zinc react with the dilute nitric acid, then it will form zinc nitrate, ZnNO3, okay, and iron ferrous nitrate and plus water and plus NO and plus NO. But in case of the concentrated nitric acid and the hot, then the copper react with the nitric acid, then it will form copper nitrate plus water and the nitrogen dioxide. In case of higher temperature, means the hot and concentrated nitric acid. The byproduct is in case of concentrated nitric acid and hot nitrogen dioxide. But in cold and dilute nitric acid, byproduct is your nitric oxide. And metal Fe, aluminum, cobalt and the nickel become inert when treated with the pure concentrated nitric acid. Okay, metal Fe, aluminum, cobalt, nickel, all are inert with the concentrated nitric acid. It is due to the formation of extremely thin layer of the insoluble metallic oxide which stop the reaction. Okay, means that it is due to the formation of extremely thin layer of insoluble metallic oxide which stop the reaction. Means the high temperature and the concentrated nitric acid not react with the metal, for example iron, aluminium, cobalt and nickel. Next is your passivity can be removed. Passivity removed by the rubbing the surface of the sandpaper and with the strong reducing agent. With the strong reducing agent, note dilute nitric acid is generally considered typical acid except for its reaction with metal since it does not liberate the hydrogen. Okay, means the dilute nitric acid is a generally considered typical acid except for its reaction with a metal since it does not liberate the hydrogen. It is a powerful oxidizing agent. The nascent oxygen form oxidize the hydrogen into water. Okay, you know very well hydrogen nitric acid is a powerful oxidizing agent and the oxidizing agent of the nitric acid is due to the presence of the nascent oxygen. Okay, very dilute 1% acid react with the magnesium nitric acid, very dilute, then it will form the what? Magnesium nitrate and hydrogen. Mn, manganese react with the even nitric acid, then it will form the manganese nitrate plus hydrogen. This reaction proves that nitric acid contains the also hydrogen. Okay, this reaction proves the what? Nitric acid also contains the hydrogen. Got it everyone? Next is your reaction with the aqua regia. You know very well the aqua regia. Aqua regia is a what? Concentrated nitric acid and the concentrated HCl. Okay, both are taken in the ratio 1:3. Then it will form the nitrosyl chloride and the water and the nascent chlorine, and it is also called the royal water. And nitric acid oxidize hydrochloric acid into the chlorine mixture react with the even gold and platinum. Mixtures react with the even gold and platinum. Platinum react with the nascent chlorine, then it will form the platinum chloride. It is soluble. Okay, gold and this nascent chlorine react with the iron gold chloride. Okay, it is soluble. Next, next topic is your uses of nitric acid. Uses of the nitric acid. Nitric acid act as a solvent and to its design on the copper and the brass ware. To its design on the copper and the brass ware. So it's a uses of the nitric acid. And nitric acid act as a solvent and to purify gold and act as a rocket fuel of oxidant. Okay, rocket fuel of oxidant and the preparation of fertilizers, and also use of the nitric acid is in the fertilizers, calcium nitrate, ammonium nitrate, nitro chalk chalk. Ammonium nitrate and the calcium carbonate is called what? Nitro chalk. And calcium oxide in the calcium nitrate is called basic calcium nitrate in the preparation of the aqua regia. So 5 is uses of the nitric acid. Next, industrial uses of the nitric acid. Explosive, explosive like the TNT, trinitrotoluene. And toluene, it is a what? CS3. When the CS3 group is attached from the benzene directly, and the artho, para, and this is a artho, means the it is what? TNT, tri 1 2 3 trinitro, and this group is called toluene. TNT is a explosive in a nature, and also uses the in the formation of synthetic fiber, and also the uses the important compound like the nitrate. Okay, nitrates of sodium, ammonium, and the silver, and also used in the dyes, formation of the dyes, drugs, and perfume. Okay. Next is your the test for the nitric acid and the nitrate. Test for the nitric acid and nitrates. Nitric acid on heating, it will give the brown fumes of the nitrogen, dioxygen, and gives also give the oxygen and water. So on heating it will give the brown fumes. Okay. And the second, nitrate produce reddish brown fume of the nitrogen dioxide. On heating the metallic nitrate, okay, it will give the metallic oxide, nitrogen dioxide, and oxygen. Third, on adding copper to the nitric acid or acidified nitrate, it will give the copper nitrate, water, and nitrogen dioxide. Similarly, copper react with the sodium nitrate and the sulfuric acid. On heating, it will give the what? Sodium hydrogen sulfate, copper nitrate, water, and the nitrogen dioxygen. Okay. Next, brown ring test. Brown ring test procedure to the solution, to the aqueous solution of nitrate or nitric acid. Okay, to the aqueous solution of nitrate or the nitric acid, add freshly prepared saturated solution of the iron sulfate. Now add concentrated H2SO4 acid carefully from the sides of the test so that it should not fall the drop wise in the test tube. Clear? So first of all you will do what? In the first step, aqueous solution of nitrate or the nitric acid, first of all prepare the freshly prepared saturated solution of iron sulfate. Then add a concentrated sulfuric acid carefully from the side of the test so that it should not fall dropwise in the test sidewise. Okay. Cool the test tube in water. Cool the test tube in water. A brown ring appears at the junction of the two liquid. Here brown ring, okay, brown ring appears at the junction at the two liquid. It is a what? Brown ring test, and the brown ring test is used for the nitric acid. Okay, it is what? Iron sulfate and the plus what? Nitric acid, sidewise the concentrated H2SO4. Clear? Then here the form what? It is a sulfuric acid and it is the ferrous sulfate. Here form the what? Here brown ring of the FeSO4.NO. Clear? FeSO4, H2SO4 react with the nitric acid, then it will form the ferrous sulfate, water, and the nitric oxide. And this ferrous sulfate and with the react with the nitric oxide form the nitroso ferrous sulfate brown compound. Got it everyone? So it is all about the brown ring test. Next, a freshly prepared ferrous sulfate solution is used, okay, because on exposure to the atmosphere it is oxidized to ferric sulfate, which will not give the brown ring. Okay, so freshly prepared ferrous sulfate solution only used because on exposure to the atmosphere it is oxidized to the ferric sulfate, which will be the not give the brown ring. That's why always shows the take the freshly prepared the ferrous sulfate. The brown ring of the nitroso ferrous sulfate is formed at the junction of the two liquid. And the third last point, the brown ring of the nitrosoferrous sulfate decomposes on heating the test tube. Okay. Effect of the heat on nitrate. Effect of heat on nitrate. Sodium nitrate on heating. Sodium nitrate on heating. Sodium nitrate. Sodium nitrite, okay, plus it will give the oxygen, slightly deliquescent. And similarly potassium nitrate on heating, it will give the potassium nitrite, and oxygen, it is a colorless crystalline. All other nitrates except those of the Ag and the Hg decompose into their oxide NO2 and O2. All other nitrate except those of the Ag and Hg decompose into their oxide NO2 and oxygen. Clear? Calcium nitrate on decomposition it will give the calcium oxide plus NO2 and oxygen. Similarly zinc it will give the zinc oxide, lead oxide and the copper oxide. Clear? Next, reaction with the silver and the mercury nitrate. It is a lunar caustic AgNO3 white corrosive. On heating it will give the silver, nitrogen dioxide and oxygen. Mercury nitrate on heating it will give the Hg, nitrogen dioxide and oxygen. And ammonium nitrate on heating it will give the N2O plus water vapor. Ammonium nitrate decomposes explosively, leaving behind no residue. Okay, and the end it is all about the water nitric acid. I hope you understand this chapter nitric acid. Please write and make the notes in the fair copy. Okay, and once time please revise it, and this chapter is a very important for exam point of view. And the next time we will meet with the new topic, okay, and with the new chapter. Okay, yes, thank you everyone.